We often think our modern obsession with huge numbers, terabytes, light years, market caps, is a totally new thing. But what if I told you that an ancient civilization basically engineered a system to name numbers so big they make a terabyte look like pocket change? Today, we're going to dig into an incredible piece of linguistic technology from ancient India. All right, let's jump in.
Okay, first just take a second and look at this number. That is a 1 followed by 62 zeros. To put that in perspective, scientists estimate the number of atoms in the entire observable universe is somewhere around 10 to the 80th power. So this number is playing in the same cosmic league. And the truly mind-bending part? This didn't come from some 21st century supercomputer. Nope. Its origin is way, way older. Right, so this number shows up in the Sanskrit epic the Ramayana, and it's describing the size of a divine army. Now, sure, you could argue about whether it's literal or a metaphor, but honestly, that kind of misses the most fascinating point. For anyone who appreciates systems, who loves engineering, the real question isn't if the army was that big. It's something much more fundamental.
Yeah, how did a civilization thousands of years ago come up with a system that was robust enough to not just think of, but to precisely name a number this massive? I mean, they didn't just point to a 1 with a sea of zeros after it. They had a specific word for it. A word generated by what you could almost call a linguistic algorithm. So let's break down exactly how they pulled it off.
It turns out that that huge number from the Ramayana wasn't some random one-off. It was actually part of a much deeper intellectual current that was flowing through ancient Indian thought. This fascination with the truly immense, it was woven right into their philosophy, their cosmology, their spirituality. Trying to quantify the universe was a serious intellectual project, and that demanded a number system like no other. And this quote right here from the Chandogya Upanishad, this is it. This gives us the core motivation, the why behind this whole thing. See, this wasn't just about counting your sheep or your soldiers. It was a philosophical drive to try and grasp the very nature of infinity, which they saw as the ultimate source of reality and joy.
So the key thing to get is that this need for giant numbers came from asking the biggest questions you can possibly ask. These thinkers were trying to map out a universe of infinite scale. They were trying to calculate these massive astronomical cycles called yugas that spanned millions of years. And they were trying to put words to Jainist concepts of time that make our geological timescale look like the blink of an eye. To even start tackling those problems, you need a seriously powerful number system.
And this just shows you how widespread it was. We already talked about the Ramayana and its 10 to the 62. But look at this. The Buddhist Lilita Sutra, it lists out powers of 10 that go all the way up to 10 to the power of 421. And then you've got Jaina texts working with numbers so huge they could only write them as powers, like this one, 8,400,000 to the power of 28. Just wow. Okay, so we've seen the what, these absolutely staggering numbers, and the why, this deep philosophical quest. So now for the really cool part, the how. How in the world did they build a system that could handle these magnitudes? Well, it turns out it was all based on this really elegant and perfectly logical set of rules, that linguistic algorithm we talked about, for generating any number name you could think of. Let's see how it works. The entire system, this whole beautiful machine for creating massive, crystal clear number names, it all rests on just 3 simple yet incredibly powerful linguistic principles. Think of them like the core functions in a piece of code. Once you get these 3 rules, you'll see how any number, no matter how big, could be expressed with absolute precision.
All right, rule number 1, and this is the big one, the multiplicative principle. This is the engine that generates all that scale. The system is base 10, just like what we use. But here's the key difference. They had unique single-word names for a whole bunch of powers of 10. Sahasram for 1,000, Ayuta for 10,000, and on and on. This rule lets you just smash a simple digit name together with a power of 10 name to create a new word for their product. Here's a perfect, simple example. The word Ashta Sahasram. It's a single compound word, and it literally means 8,000. You just fuse Ashta, which is 8, with Sahasram, which is 1,000. This is the backbone of the whole thing. It lets the system scale up practically forever, just by coming up with new names for higher powers of 10. Okay, rule 2 is the additive principle. This is how you fill in all the gaps between those nice, clean powers of 10. And the logic is just so consistent. I mean, unlike English, where we have weird words like 11 or 13, the Sanskrit system has a very simple rule. You say the smaller unit first, then the larger one.
So for example, to say 45, you'd say panchachatavarimshat. This is literally 5 and 40, or maybe 5 upon 40. You name the smallest unit, 5, pancha, then the next order of magnitude, 40, chatavarimshat, and you just add them together. This structure makes the number totally unambiguous and super easy to figure out, every time. It's a model of logical consistency. And finally, the system had this really clever bit of flexibility built right in, the subtractive principle. You can think of it as an elegant little shortcut, especially when you're dealing with numbers that end in 9. Instead of adding a 9, it was often just cleaner to say it as 1 less than the next multiple of 10. So for the number 29, you could say ekonatrimshet, and that breaks down to 1 less than 30. It's not just some weird quirk, it's an efficient little hack built right into the language. It just shows this deep, intuitive feel for how numbers relate to each other and, well, a preference for linguistic elegance. It's another sign of how sophisticated this system really was. So when you put it all together, you have this deep philosophical need to explore the infinite, and then you have the systematic 3-part linguistic algorithm for naming any number you want. What you see is a picture of just incredible mathematical sophistication. This was not poetic exaggeration. This was precision engineering, just using language as the main tool. So, the big takeaway here is this. The whole quest for these colossal numbers in ancient India was anything but trivial. It was born from this really profound need to try and quantify the unquantifiable. And to meet that challenge, they designed a brilliant, rule-based system that could name any number they could imagine with perfect clarity. It's this fusion of deep philosophy and hardcore logic that just makes it so remarkable.
It really makes you wonder, doesn't it? I mean, if a system this sophisticated existed thousands of years ago, a system that could seamlessly weave together language, mathematics, and philosophy, what other marvels of logic or science or engineering are still just sitting there, waiting to be rediscovered in ancient texts? What other forgotten algorithms are hiding in plain sight, just waiting for us to finally decipher their code?